Hello, welcome to the video. In this lesson, we're going to be looking at section 7.4, where we're going to look at properties of special parallelograms. So what we've talked about in previous lessons is a parallelogram essentially is a quadrilateral that has two sets of parallel lines. So, we have our parallelogram here. These two sides are parallel, and these two sides are parallel. All right. From that characteristic, we have other more specific parallelograms that possess other characteristics, such as rectangles, rhombuses, and squares. We're going to take a look at what makes those types of parallelograms those specific names, and then see how we can use those characteristics to determine what kind of a parallelogram, or well, at least what kind of quadrilateral we're looking at. So when we are looking at a rhombus, a rhombus is a parallelogram, more specifically with looking at its side measurements, and those side measurements have four congruent sides. A rectangle is a parallelogram that has four right angles in the interior, and then a square is a parallelogram, but it's kind of a combination of a rhombus and a rectangle where its four sides are congruent and it has four right angles. So we have some corollaries to help, to help us figure out what uh, what shapes create rhombuses, what shapes create rectangles, and what shapes create squares. Basically, these are just telling us what we knew from the description on the previous page. So in this passage here, it says, for any rhombus QRST, they need to decide whether the statement is always true or sometimes true. Okay, so let's just say I drew out a rhombus here, and so we have a rhombus, and we got Q, R, S, and T. Okay, so the first thing is they drew a diagram, which we did. They wanted you to show if angle Q is congruent to angle S. They want you to say like, oh, what is it always true, or is it sometimes true for Q to be congruent to S? Well, it doesn't matter what kind of rhombus, if we have a rhombus or if we have it as a square, it is going to be congruent, because not only is this a rhombus, it's also a parallelogram, and a parallelogram says that opposite angles are congruent. So this is a situation where we're going to have always. This is always going to be true. All right, now looking at part B, they want to know if angle Q is congruent to angle R. By the looks of the drawing that we just did for A, it would not be true. But is there a situation where I could have a rhombus and it would be true? So here's a situation where if you had a rhombus, but you had four right angles. So essentially, if your rhombus was a square, Q and R would be congruent. So this would be a situation for part B would be sometimes. All right, and then this particular slide, it says classify the special quadrilateral. Anytime they ask you to classify, we are only allowed to make assumptions about the figure for whatever information they give us, okay? So for instance, not looking at this diagram, but if I just drew this and I gave no measurements, I gave no right angles, nothing. Um, if I gave no right angles, no congruent measurements or anything like that, you know, it may look like a square or it may look like a rectangle, but there's nothing I can prove. So all I could say right now is this is a quadrilateral, okay? But since we're looking at the diagram here, what I want you to look at is, well, it shows us 4 hash marks, which means that all 4 sides are congruent. And we have an interior angle that's 70 degrees that shows that it's not 90 degrees. So that means the most specific name for this is a rhombus, because it has four congruent sides, and the most specific name is a rhombus. Speaking of rhombuses, we have some other theorems that we can look at. Is if your parallelogram is a rhombus, if we are looking at the diagonal measures, first, when our diagonals bisect, it's not only going to bisect, but it's also going to be perpendicular. Also, something we can look at with the diagonals, um, they are also angle bisectors. So when they cut the angles in half here and also here. So using that information, that is going to help us solve different problems. All right, so in this particular situation, they want us to find the measurements of angles 1, 2, 3, and 4. All right, they're telling you that it's a rhombus. So when they tell you it's a rhombus, that means it possesses all the characteristics of a rhombus. So with that being said, let's go in and start solving some of these problems. So first off, what I know is, like with angle 1, because I have 2 diagonals here, I know that it intersects at a 90-degree angle. So I can tell you that angle 1 is 90 degrees. I can tell you that angle 2 is going to be 61 degrees because of alternating interior angles. I can tell you that angle 3 is also going to be equal to 61 degrees because of the rhombus opposite angles theorem. I know that that diagonal bisects that angle A. And then finally, angle 4, I can figure that out. Well, if this is 90, I know this is 90. And then I can determine what, using triangle sum theorem, 180 minus 90 minus 61, that gives me 29 here. That means it's 29 here because it bisects. So angle 4 is 29 degrees. So knowing all that, I know these are the 4 angles that they were looking for. To kind of add on, they were looking at example 3. They want you to find the measurement of angle ACD and BCD. So if you recall, ACD is, or I'm sorry, ADC, which is right here, which is essentially going to be 29 plus 29. That is 58 degrees. If you looked at angle BCD, that one's going to be 61 plus 61, and that is 122 degrees. All right, one of the ways you can check, I would say if you took 58 times it by 2, and took 122 and times it by 2, add them together, you should get a result of 360 degrees. Looking at number 5, they're wanting us to find the measures of the angles in rhombus DEFG. So what's nice about this, again, because it is not also a rhombus, but it is also a parallelogram, I know that whatever this angle is going to be the same, and they bisect. So whatever the measurements of angle 1 and angle 2 are going to be the same as angles 3 and angles 4. So that means that 1 and 3 are going to be the same. So what we have here is like a triangle DGF, and that is an isosceles um, triangle because we have they're going to be the same angles. So using triangle sum theorem, I can take 180 subtracted by 118 and then divide it by 2. So I get 31. So angle 1 is going to be equal to angle 2, which is going to be equal to angle 3, which is going to be equal to angle 4, which is going to be equal to 31 degrees. Here we have, it says rectangle diagonal theorem. So it says when the diagonals intersect, their diagonals are congruent. So this is another characteristic for rectangles. So with that being said, here it says you are building a frame for a window. The window will be installed in the opening shown in the diagram. The opening must be a rectangle given the measurements in the diagram. Can you assume that? The answer is no, because there are no right angle marks and there are no right angle marks. So there's no way to assume that they are right angles. Now, maybe not necessarily have any right angle marks, but you could also, if they gave us measurements for the diagonals, and if they happen to be the same, we could go from there, all right? But I think they talk about that in the next question. So here it says that they measured diagonals of the opening. The diagonals are 54.8 inches and 55.3 inches. What can you conclude about the shape of the opening? Well, we can conclude that it's not a rectangle. All right, that's what we can conclude. Here it says that we have a rectangle. Since we have a rectangle, it says that QS and RT equal these values. 5x minus 31 is QS, and RT is 2x plus 11. They want us to find the length of the diagonals. So in order to find the length of the diagonals, we have to find x. So since QS and RT are going to be equal to each other, I can take 5x minus 31 and set it equal to 2x plus 11. Subtract 2x, so I get 3x. Add 31, I get 42. Divide both sides by 3, x is 14. All right, that doesn't tell us the measurement of the diagonals, so I have to choose one. So if I just choose, say, the RT, 2 times 14 is 28 plus 11 is 39. So my diagonals are 39 units. Here it says they want you to decide whether parallelogram PQRS with vertices -5, 2, 0, 4, 2, -1, and -3, -3 is a rectangle, rhombus, or square. Give all names that apply. So let me get a graph here. So if I plot these points, -5, 1, 2, 3, 4, -5, 2. So that's P. And then we got 0, 4, 1, 2, 3, 4. That's Q. We got R, which is 2, -1. And we got S, which is 1, 2, -3, 1, 2, -3. So we got S. So we got all right, so the first thing I'm going to do is I'm just going to check the slope. So this one is what? 1, 2, 3, 4, 5, 6. Oh, sorry. 1, 2, 3, 4, 5. So it's -5, 1, 2. So PS is -5/2. So let's look at this. So it's 1, 2, 3, 4, 5, 1, 2. So that's so those two are parallel. So we know it's at least um, parallelogram. So what I want to do is I want to check this slope here. 1, 2, 1, 2, 3, 4, 5. So SR is positive 2/5. So what this means is that they are 90 degrees. So we know that it's at very least a rectangle. Now what I want to know is PQ and like say PS the same? So if I took and found the distance to PQ, this is going to be equal to the square root of, um, let's say 0 minus a -5 squared plus 4 minus 2 squared. So that gets me what? 5 squared, which is 25, plus 4 minus 2, which is 2. Square that, it's just 4, so square root of 29. So I'm going to say square root of 29. All right, now I want to find PS. So I want to see if it's the same thing. So this is going to be -5 minus a -3. Square that plus 2 minus a -3. Square that plus 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 plus. -5 plus 3 is 2. -2. Square that, which is 4. That gives me 5, so this is giving me square root of 29 as well. So what I have is not only 4 right angles, but I also have 4 congruent sides. So it is a rectangle, it is a rhombus, and it is a square. So it's all of those things apply. And that is being able to look at properties of special parallelograms. Hope this helps. Till next time.